Thank you very much for attending this session. This would be a long talk, which I partitioned into perhaps 6 parts, and I upload each part individually. So each part would be short, but in total I think we may go 45 minutes or even more in all 6 talks. We'll talk about choosing among alternatives, decision trees, transforming monetary values into utilities, prior and posterior probabilities, sensitivity analysis, and software like Silver Decisions and Analytical Solver to solve tree computations more easily and be able to solve larger problems. Choosing among alternatives. Let's look into this problem. We have a firm. They have a piece of land. They can sell it or they can drill it. If they sell it, they will get $90,000. If they drill it, the initial cost is $100,000 for drilling. Drilling may have 2 outcomes. The land may be dry. In that case, this $100,000 is gone. Or they may see oil. In that case, they will get $800, and they have spent $100, so they will get $700,000. This is the statement of the problem. If they drill, probability of oil is 1 in 4, and probability of dry is 3 in 4. So that probability is 0.25 or 25%, and this probability is 1 minus 0.25 or 75%. Let me introduce a couple of terms in decision trees. Decision maker is the individual or group responsible for making decisions. Alternatives, the option for the decision maker. Chance event, an uncertain future event that affects the consequence associated with the decision. Something will happen in future when we make a decision. What happens is out of our control. Going through that road is in our control. But what happens over there is out of our control. State of nature. So in the example that I discussed, we have sell alternative and drill alternative. For sell alternative, the state of nature is 100% known. With 100% probability, we will get $90,000. But if we drill, there are 2 states of nature which are out of our control. Selling the land or drilling is in control. It's a decision that the decision maker makes. These 2 alternatives are available for the decision maker. But what happens after we decide to drill is out of our control. We may see oil or we may end up with a dry land. Oil and dry land are known as state of nature. Outcomes are the result of a combination of decision, alternative, and state of nature. So if we decide to drill and if the land is dry, the outcome is dry land, and the payoff associated with that dry land is $100,000 that we spend plus $0. If it is oil, the payoff is $100,000 negative plus 800 positive, which makes it 700,000. We will have prior probabilities and posterior probabilities. We will discuss them later. Now let's talk about a couple of approaches. We refer the first approach as MaxiMax. So we have two alternatives, drill or sell. There are two states of nature, oil or dry. The outcome for sell the rand is 90 and 90. The outcome for drill is 700 and negative 100. In MaxiMax strategy, we will go through each decision. What is the max we could get here? 90. What is the max we could get here? 700. Which one is higher? MaxiMax. We found max in this row and max in this row, and wanna find maximum of these two maximums, and that's it. Therefore, the decision is drill for oil. Let's look at the second, MaxiMin. This is one alternative. This is another alternative. What is the mean case that can happen here? MaxiMin. What is the mean? 90. What is the mean that can happen here? Minus 100. MaxiMin. These are means. Which one is maximum? This one. Therefore, go for this decision. MaxiMax. MaxiMin. Regret. MiniMax Regret. This is a little bit more complicated than the previous one. Find regret and then minimize the maximum regret. Here, if this state of nature happens, the maximum that we gain here is 700. So we subtract 700 from 700 and we get 0. If we choose this alternative, our regret is 700 minus 90, which is 610. If the second state of nature happens, in this problem, we do have two states of nature, dry land or finding oil. If this state of nature happens, the best we can get is 90. So what is the regret of this 90 with respect to 90? 0. But if we have made this alternative, we have made this decision, outcome would be negative 100, while we could have 90 profit. 90 minus negative 100 is 190. Now this is our regret table. This alternative has maximum regret of 610. This alternative has maximum regret of 190. We want to minimize the maximum regret, and therefore we choose this alternative. Maximum likelihood. This is how it works. Look at probabilities and find the maximum probability, which is here. And then we will choose the alternative that has the highest payoff. This one has a payoff of 90. This one has a payoff of negative 100. Therefore, the highest is here, and we choose this alternative. So in step 1, we find the maximum probabilities, maximum likelihood. And in step 2, the one which provide maximum payoff. Now let's consider expected values. We have two alternatives and two state of nature. For alternative drill, we may get $700,000 with probability of 25%, and we may lose $100,000 with probability of 75%. If we do these multiplications, 0.25 multiplied by 700 plus 0.75 multiplied by negative 100, we will get 100. That is expected payoff of the first alternative. For the second alternative, which is sell the land, there is 25% probability that we get $90,000 and 75% probability that we get $90,000. And these two probabilities together are equal to 1. Therefore, the expected value of the second alternative is 90, and the expected value of the first alternative was 100. Therefore, among these two, we will go for this alternative because it has a higher expected value and real. However, when we make a decision based on expected value, we should visualize all the potential outcomes. For example, in this situation, there is 25% probability that we gain $700,000, and there is 75% probability that we lose $100,000. 700, this is the probability, and negative 100, this is the probability. And then the decision maker can check whether for an expected value of $100,000, do the decision maker is willing to have a risk of negative $100,000 for 75% probability, or the decision maker wants to just go with $90,000 with 100% probability. Now let's do a little bit practice. Practice on how to create a payoff table and practice on how to use those MaxiMax, MaxiMin, Min Regret approaches we learned. We practice by using an example which preparing the payoff table is not very straightforward. There is a product, we can buy it from outside or we can make it inside using two alternatives. If you buy it, the cost is $11 per unit. If you manufacturing inside, you have a intermediate process, which its fixed cost is $70,000 and variable cost is $7, something like this, 70, and then goes up. Or alternatively, we can use an advanced alternative, which its fixed cost is higher, but its variable cost is lower. This is general rule. When fixed cost goes up, generally variable cost comes down. Sale price is $12 per unit. We have three states of nature: small market, medium market, and large market. Payoff table is our profit under each of these circumstances. Profit is revenue, which is price times quantity, minus fixed cost, which is there no matter we produce or not, minus variable cost per unit times the number of units produced. And if we factor Q out of PQ and VQ, our profit is P minus V times Q minus F. That is how we can compute profit. So here, for example, in this situation, market is 10,000, sell price is 12, purchasing cost is 11. On each product we make $1, therefore $10,000, $20,000, $30,000 under each of these. For this alternative, for example, suppose you want to compute it for this one. That is P, which is 12, minus V, which is 7, times Q, which in this case is 20,000, minus F, which in this case is 70,000. So that is 5 times 70,000, which is 100,000 minus 70,000, which is 30,000. And if, for example, we want to compute this item here, this is advanced technology for 30,000 cells. For advanced technology, price is still 12. Variable cost is 4 times 30,000 minus fixed cost, which is 140,000. 30,000 times 8 is 24,000 minus 140,000, it is 100,000. So that is how we compute the payoff table. Now I have payoff table here. These three payoff tables are exactly the same. Let's practice MaxiMax. For buy, this is max. For make 1, this is max. For make 2, this is max. Max of all maxes is this. So under MaxiMax strategy, we will go for make 2. Now for MaxiMin, here min is 10,000, here min is 20,000 negative, here min is minus 60,000. Out of these three means, this one is max. So we go for that one. Now practice expected value. Expected value for this one is 10,000 times 0.25, which is 2,500. 20,000 times 0.35, which is 7,000. And 30,000 times 0.4, which is 12,000. If we add them together, the same for all others. And out of these three, this one is maximum, so we go with this alternative. Here we went with that alternative, here we went with this alternative. Let's also look at maximum regret. This is our payoff. This is small market, this is medium market, this is large market. Those three states of nature. We will go to this one. What is the best situation? This is 10,000. So if state of nature is small and if we have gone with this strategy, our regret is 0. For make 1, our regret is equal to this maximum minus this one, which is 30,000. Regret for the third alternative, if state of nature is small and we have gone with third alternative, we could have gone with the first alternative and we could have made 10,000. Now we have lost 60,000. So 10,000 minus 60,000 is 70,000. That is our regret here. For the second state of nature, medium market, we look at these three. The maximum of these three is this one. So regret for that one would be 0. For the first one, it is 30 minus 20, which is 10,000. And here again, 30 minus 20 is 10,000. If a state of nature is large, I have these three situations. The best one, the maximum, is this one, so regret for that one is 0. But for this one is 100,000 minus 80,000, which is 20,000. And for this one is 70,000. So I can easily compute regret table. So this is the maximum of state 1, maximum of state 2, maximum of state 3. We subtract each payoff from this maximum. Here I will get 0, 30, 70. Here 10, 0, 10. And here 70, 20, and 0. maximum regret is 70,000 here. Maximum regret is 30,000 here. Maximum regret is 70,000. Therefore, it is alternative make 1, which minimizes the maximum regret. Minimization of maximum regret. This concludes the first piece of my talk on decision tree analysis. I will have several talks on this subject. I try to keep all of them something between 15 and 20 minutes. See you in my next talk, which I will conduct a simple sensitivity analysis. In the later parts of my talk, we will conduct a more complicated sensitivity analysis. Thank you very much for attending this talk.